All right, so today we're really diving into the thick of it with AI.
Yeah,
Those
yeah.
large language models,
Absolutely.
LLMs as they're called, they can write you a poem,
Mm.
they can answer your questions, they can even do code for you.
Yeah, they can do it all, it seems like, these days. It's really changing everything.
It is. But, you know,
Always a but.
there's always a but. They need so much power.
Yeah.
Like you need these massive data centers.
Huge amounts of processing power.
Yeah. And then there's the privacy thing too, right?
Mm-mm.
We're sending all our data to the cloud.
Exactly. And that's a big concern these days. People want to keep their data private, keep it on their own devices if they can.
For sure. So how do we solve for that? That's where this paper comes in. TPI-LLM, serving 70B-scale LLMs efficiently on low-resource edge devices. And they are taking on that challenge head on. Can we get these big LLMs onto something like your phone?
Yeah, and it's really interesting because for so long, people thought, well, edge devices, things like phones and laptops, they just don't have the horsepower to run these kinds of models. But this paper is saying, hold on, maybe there's another way.
Yeah, like maybe we've been thinking about this the wrong way all along.
Potentially.
So what's the secret? What are they doing differently?
Well, they started by asking some really fundamental questions, challenging some assumptions we've had about edge computing. Like, what if just shrinking down the models isn't the answer? What if the real bottleneck is how we share data between devices?
Oh, interesting. So instead of focusing on making the AI smaller,
Right.
it's about making the whole system work together better.
Exactly. To test this out, they took an 8B LLM, the Llama 3.1 8B model to be precise, and ran it on a network of laptops. Something a lot of people might have in their homes. And what they found is that our traditional ideas about network limits, they might not be telling the whole story.
So like, we're assuming the freeway is jammed, but maybe everyone's just taking a different route.
Yeah, that's a great analogy.
Okay, so that's one piece of the puzzle. But then there's the other big question, right?
Absolutely.
Even if we could figure out this whole data sharing thing,
Yeah.
can these devices, which are less powerful, actually handle all that information, all that processing?
It's a huge amount of data, and it's not just about the size of the model itself. It's about all the stuff that gets generated during the process. It's like, baking a cake. You might have a big enough oven, but do you have enough counter space for all your ingredients and bowls?
Oh, I feel that in my soul. My counters are way too small. So what happens in the AI world when you run out of counter space?
Well, things can get messy very quickly, and that's where TPI-LLM steps in with a new approach.
Okay.
Now, you might have heard of model parallelism, where you split the AI tasks across different devices.
Right, like each device gets a piece of the puzzle to work on.
Exactly.
So how does this TPI-LLM, how does it actually work?
Well, let's stick with that puzzle analogy, right?
Okay.
So first, we have what's called the master node.
Master node, okay.
This is like the team leader. They've got the puzzle box. They see the whole picture, and they're making sure all the pieces end up in the right place.
Right.
In TPI-LLM, the master node is where you put in your prompt. So that's like your picture on the puzzle box.
Okay.
It's also where the AI spits out the final text, your completed puzzle. And here's a key part. That prompt never actually leaves the master node, so it stays private.
Oh, okay, that's good to know. So the master node is really kind of the brains of the operation.
It's orchestrating everything.
What about the other devices then? What are they doing?
So those are our worker nodes.
Worker nodes, got it.
Think of them like the team members putting the puzzle together.
Okay.
Each worker node, it gets a bunch of puzzle pieces, and in this case, the pieces are chunks of the AI model's weights.
So they're all working on their own little section at the same time.
Exactly, working in parallel, which speeds things up significantly.
Makes sense. But with a puzzle, you got to see how everything fits together.
Right.
How do those worker nodes communicate, make sure they're all on the right track?
They're asking the right questions. So TPI-LLM has this communication system built in. It's called allreduce.
Allreduce.
And it's basically how those team members share their progress, make sure everyone's on the same page.
Oh, so they're all constantly checking in with each other.
In a way, yes. But the really cool part is that TPI-LLM is made to make this communication super efficient,
Okay.
even on networks with high latency, like your home Wi-Fi.
High latency, yeah, like when your video call freezes at the worst possible moment.
Exactly. So instead of each device passing messages down the line, which can be really slow, TPI-LLM uses a star-based method.
Star-based, okay.
It's like everyone reports directly to the team leader.
Oh, that makes sense. Cuts out the middleman.
Right. And that's a big reason why TPI-LLM is so much faster and more efficient.
So we've got speed, less power consumption, and it's more private. This is sounding pretty good.
It's a pretty elegant solution.
But what about that counter space issue? We didn't forget about that, did we?
Er.
How does TPI-LLM deal with all that data, all that memory it needs during the process?
Ah, you're sharp. That's a really important point, and TPI-LLM actually addresses it head on. They've come up with something called a sliding window memory scheduler.
Wow, that sounds complicated.
It's a mouthful, but think of it this way. Imagine you've got this super organized assistant in the kitchen with you.
Okay.
They're constantly swapping out ingredients and tools based on what the team needs at that very moment.
Oh, like magic countertops. Everything appears when you need it and disappears when you don't.
Exactly. And that's basically what's happening inside TPI-LLM. It's managing those memory resources so carefully that it can handle these massive AI models without getting bogged down.
So it's not just brute forcing it, it's being really smart about how it uses what it's got.
Exactly. And that's a big part of why this is such a breakthrough.
Okay, so it all sounds great in theory, but what about in practice? What kind of results are we talking about here?
Well, the results are honestly pretty amazing. They managed to run these massive 70B-scale language models, and those are huge on just two low-power devices.
Two devices. That's it.
That's it. And this wasn't just some theoretical simulation either. They actually tested this on a network of 4 laptops using Wi-Fi, something a lot of our listeners probably have at home.
So real-world stuff, not just happening in a lab somewhere.
Absolutely. Real-world setup.
Okay, that's impressive. But how much faster are we talking? What's the actual improvement in speed?
Well, they saw up to 80% faster time to first token compared to other systems. And that time to first token, that's basically how long it takes to get the first response from the AI.
So how long you're sitting there waiting for it to catch up?
Exactly. And nobody wants to wait around for their AI to think.
Yeah, I mean, think about it.
It's huge.
If we can have this much power on our own devices,
Yeah.
it opens up so many possibilities.
Yeah.
Like, what are you most excited about with this kind of breakthrough?
Well, to me, what's so cool is that it's not just about like shrinking down the AI, right? It's about changing how we use it, how we interact with it.
Oh, interesting.
If we can run these giant models locally on our own devices, it means more personalized stuff, right? Offline capabilities.
Right.
We could see whole new types of AI applications, things we haven't even thought of yet.
Yeah, totally. It's like, remember when we needed those massive computers
Oh, yeah.
to do anything? And then we got personal computers?
Totally.
This feels like that kind of leap.
Yeah, it's a paradigm shift.
Now, this paper, they were mostly focused on text generation.
Right.
But could this TPI LLM thing, could it work for other stuff that LLMs do, like images or audio?
Oh, that's a great question. And I mean, potentially, yeah. The focus here was text, sure, but you can imagine adapting this for other LLM tasks. Image processing on your device, real-time translation, that kind of thing.
Oh, wow. Like editing videos with AI, but it's all happening right there on your phone?
Exactly. No need to upload anything.
That'd be amazing. So as we wrap things up here,
Okay.
what's the big takeaway for our listeners today? What should they be thinking about?
I think the big takeaway here is that the future of AI, it's not just about, bigger models, more data in the cloud.
Right.
It's about bringing AI to us.
Yeah.
Making it personal, making it private, and honestly, making it more useful in our everyday lives.
Yeah, taking that power and putting it right in our hands.
Exactly.
Yeah.
That's what this is all about.
That's a great point to end on, I think. So we'll leave you all with this thought. What will you do with that power? 70B scale AI right there in your pocket.
That's it for our deep dive today. Thanks for joining us.